Welcome back. This is the second Anaqsim tutorial, and we're building on what we covered in the first video. We'll start by rebuilding our initial model using the HSEG boundary generator. Repeating these steps will take a little longer, but it'll help reinforce the model building process from the last tutorial. Then, we'll take it a step further by adding a subdomain. In Anaqsim, subdomains are often used to create discrete geological features like clay lenses and infilled sand channels. Let's begin by sketching out our conceptual model so you can visualize what we're building. We'll use the same circular HSEG boundary setup, then add a subdomain with different aquifer properties to simulate its effects on groundwater flow. For this example, we'll add a simple infilled channel made of low-permeability material to demonstrate how to work with subdomains. At the end, you'll be able to explore how to change the size and shape of this feature, an essential skill for real-world projects where testing assumptions and redesigning your model as new information comes in is critical. Let's create a new model. Open Anaqsim, go to Model Input and select General. Check the steady state box to show this isn't a time-dependent simulation. For units, we'll use meters for length and days for time. Finally, let's name our file Tutorial2 and save it by going to File and clicking Save. Our next step is to define our model domains. This time, we'll define two domains, one for the main aquifer and one for our silt channel subdomain. Let's start with the main aquifer domain. Click Model Input and select Domains from the drop-down menu. Choose Confined and/or Unconfined to let Anaqsim know we're working with an unconfined aquifer. An input table will appear. This is where we'll describe the aquifer properties. In the Label Unique field, type a simple description like Aquifer. Under Level, select 1 and choose Unconfined as the domain type. Set the top elevation to 50 meters and the bottom elevation to 35 meters to represent the base of the aquifer. For average head, enter 47 meters, just below the top elevation, giving us an average saturated thickness of 12 meters. We'll keep the default values for porosity, storativity, and specific yield. For hydraulic conductivity, or K values, enter 24 meters per day for K1, K2, and K3 to create a homogeneous model. Ignore the angle K1 to x-axis field for this example. Now, go to File and click Save to save your domain input. That completes our main aquifer domain setup. Next, we'll create our silt channel domain. In the Label Unique field, type a unique description like channel. If you only see one input line, left-click on the available line, press Enter, and a new line will appear. For the channel domain, repeat the same values from the main aquifer domain, but this time set the hydraulic conductivity, K values, to 0.4 meters per day for K1, K2, and K3 to create a homogeneous subdomain. Feel free to pause the video if you need more time to fill in all the input values. After creating the domain, our next step is to define the model boundary. This sets the horizontal extent of your simulated aquifer. In this example, we'll define boundaries for both our main aquifer and our silt channel. Let's start with the main aquifer using the HSEG boundary generator again. Go to Model Input, choose Line Boundaries from the drop-down menu, and then select Head Specified External with Gradient from the next drop-down menu. An input table will appear. First, select Domain, and you'll see a drop-down menu with all the domains you've created. Choose your main aquifer. Next, set the center of the domain using XY coordinates. For this example, enter 0, 0. Now, fill in the radius, gradient, and gradient direction fields. Radius, 2,000 meters. Gradient, 0.0001, a 1 meter drop in groundwater level over 10,000 meters. Gradient direction, 135 degrees, in polar coordinates, pointing northwest. Click Parameters per line, and select 3 from the drop-down menu. We'll cover line parameters in more detail in future videos. Now go to File and click Save to save your input. To create the silt channel subdomain, we'll need coordinates to define its shape within the main aquifer domain. In a real-world project, you'd probably have coordinates for a geological feature from a GIS or CAD file, and you could simply copy those coordinates into Anaqsim. But for this example, we'll make up the size and shape of the silt channel just to demonstrate the process. We'll do this using Anaqsim's digitize tool. Before we can use the digitizing tool, we need to plot the model, so let's do that now. Start by clicking Solve in the top menu bar. Anaqsim will automatically switch to its log view, just like in the first tutorial. Next, go to Make Plot in the top menu bar and choose All Selected Features, Same Level Time. Right now, you'll only see the HSEG boundary. So, let's turn on the groundwater contour view. Go to Plot Input in the top menu bar, select What to Plot from the drop-down menu, and check the Contours box. Then, click File and Save. Now, click Make Plot again, and choose All Selected Features, Same Level Time. You'll see the simulated groundwater flowing in the northwest direction, along with the area where we'll digitize the silt channel. On the blue menu to the left of your plot screen, you'll see a list of tools at the top. Click Digitize, and from the drop-down menu, select Ellipse Polygon. A prompt will appear asking for the number of sides you want for the polygon. Choosing more sides creates a higher resolution ellipse, but also increases the number of equations Anaqsim must solve. For this example, select 10 sides and click OK. Next, move your cursor over to your model domain and left-click near the center of the plot. Drag your mouse a short distance in a northeast direction within the HSEG boundary, then left-click again to set the ellipse width. Now, drag your mouse in a southeast direction. You should see a yellow ellipse forming. Stretch the ellipse so it fits comfortably within the HSEG domain without getting too close to the boundaries. Left-click one final time, and Anaqsim will automatically record the coordinates of the ellipse. Now that we have coordinates outlining our silt channel, we can create the boundaries for our silt channel subdomain. First, go to Model Input and select Line Boundaries. From the drop-down menu, choose Interdomain, and an input table will appear. Under Label, give your subdomain a unique name like Channel. Next, you'll need to enter the Domains Left and Domains Right fields. These tell Anaqsim where your subdomain is located for the calculations, so it's important to get them right. The easiest way to think about this is to imagine walking along the boundary line in the order you specified the coordinates. If your subdomain is on your left side as you walk, it belongs in the Domains Left field. If it's on your right, it goes in Domains Right. Since we used an ellipse for digitizing, Anaqsim automatically records coordinates in a counterclockwise direction. This means the subdomain will be on the left side. So, click Domains Left and choose your subdomain from the pop-up box. Then, click Domains Right and choose the main aquifer. Keep parameters per line at the default setting of 4 to minimize the number of calculations. Finally, click the Edit button under Coordinates and paste the coordinates you copied when you digitized the ellipse. Go to File and click Save, and that's it. Your silt channel subdomain is now part of the model. We'll cover the domains left and right in more detail in later videos when we discuss more complex model setups. Now let's take a look at the results. Since we added a new feature, we need to solve the model again. Click Solve in the top menu bar. Anaqsim will switch to its log view, just like before. Once the solution is complete, go to Make Plot in the top menu bar and choose All Selected Features, Same Level Time. From the results, you can see that the lower permeability layer bends the groundwater flow as expected. We'll end this video here, but be sure to save your model and we'll build onto it in the next tutorial. In the next video, we'll modify this model by adding another layer to create a proper 3D model. For now, feel free to experiment with this model. Try changing the hydraulic conductivity on the channel domain under Model Input and Domains. You can also change the shape of the silt channel by simply changing the coordinates under Line Boundaries. And remember, because Anaqsim doesn't use a mesh, you can tweak just about everything in your simulation with just a few clicks. Thanks for watching. See you in the next one.